Hi everyone, good afternoon. Now we're going to derive the kinematics equations or the uniformly accelerating motion equations. Okay, we will be starting with acceleration. So we know that for these types of problem or for these equations to work, acceleration should be equal to a constant. Okay, so this is where the object is actually accelerating constantly. Okay, so when we say accelerating constantly, the velocity is increasing, okay, at a constant rate. All right, so we call this your kinematics equation. So we will be using these equations for most of our analysis in the one-dimension and two-dimension motion. So kinematics equation is very important, and I believe, and I should tell you to memorize this. Okay, memorize them, put them in heart, and try to know these equations because they are very, very important. All right, let's start our analysis with acceleration. So from the previous videos that I linked with you, we know that acceleration is basically x is equal to v2x minus v1x all over t2 minus t1. So it's basically a way to say that the velocity or the velocity final minus the initial velocity is all over t final minus t initial. However, we want to make it generalized, meaning anywhere in the motion, we can actually use this by substituting 2x and 1x. Okay? So, now, and we say a of x, that's basically the acceleration. There is no instantaneous acceleration because this object have a constant acceleration. So we can actually rearrange this equation by multiplying each side with t2 minus t1. And we will be left with a sub x is equal all times t2 minus t1. It's equal to v2 of x minus v1 of x. Alright? And then we can rearrange it further to reflect the final velocity. So vx now can be equal to v1x or v naught x plus a sub x multiplied to delta time. Okay? And if, for example, your time is just 0, your initial time is 0, then you can rearrange this equation to be this. And now this is our first kinematics equation. Alright? That's our first kinematic equation. Next is we're going to derive the second kinematics equation. That's the derivation for the first equation in kinematics equations. So that's Vx is equal to V naught x plus Ax times t. Alright, that's our first equation. The next equation banks at the concept of average velocity. Okay, average velocity. So we know that average velocity is equal to V average in the x-axis is equal to x minus x naught all over time. Assuming that time starts, t initial is equal to 0. So we're just making it that way para madali yung hindi tayo t2 minus t1. Okay? So it's an assumption that we are doing right now. Next equation that we need to understand is the concept of average velocity in terms of velocity only. So V average, okay, V average in x is equal to 1/2 V naught of x minus Vx, or plus Vx, I should say. So this is your average velocity. Now, note that this equation, okay, this equation is not true, okay, if the acceleration varies during this time interval. Okay, if there is a change in acceleration or the acceleration vary, it is not true, which is basically the concept of our uniform accelerated motion. Okay. We also know that with constant x acceleration, the x velocity vx at any time t is given by equation 2.8. Or actually, this equation, okay? This equation, our equation 1. So we can substitute the vx here to the vx here to incorporate the time factor into this equation. So, in substituting this to this equation, so we will now have v average in x is equal to 1/2 v naught of x plus v naught of x plus ax times t. Okay? So we now have that. And then we can actually simplify this further. V average of x is equal to 1/2 times 2 v naught of x plus ax times time. Alright? And then continuing the equation to the other side. So v average of x is equal to v naught of x plus 1/2 ax of time. Alright. And then, now, since the v average here is also the same as the v average here, we can equate them both. So, we can equate them. So, x minus x naught over time is equal to v naught of x plus 1/2 ax of t. And then, multiplying both sides by time. So, we can now have the following. X minus x naught is equal to v naught of xt plus 1/2 ax t squared. This is now our second kinematics equation. Okay, second kinematics equation natin yan. Alright, so now we have two equations for the kinematics equation, right? So let us just summarize them. The first equation is Vx is equal to V naught x plus a sub x times time. The second equation was x minus x naught is equal to V naught of x times time plus 1/2 a sub x times t squared. So these are your two equations so far. The third equation will be using these two equations. We'll combine them and let's see how it gets. Okay? So we will be using the first equation and then express it in terms of time. Alright? So in terms of time. So in expressing the first equation in terms of time will lead us to Vx is equal to V naught of x plus ax times time. And then we can substitute transfer v naught of x to the other side is equal to ax times time, dividing both sides by time. Now we're getting, not dividing both sides by time, dividing both sides by a sub x. Now we have time is equal to vx minus v naught of x all over a sub x. Next is we will now substitute the time here into the time here. Okay? So we will substitute this equation into this equation. So doing that will give us x minus x naught is equal to v naught of x times v of x minus v naught of x over a sub x plus, okay, 1/2 a sub x times v naught of x, vx minus v naught of x all over a sub x. Okay, squared. I should not forget the squared. Okay, doing the simplifying all the equations, we will be left with, okay, so how do we simplify this? Basically, we can multiply both sides. Let's first simplify all the numerators. Okay, numerators muna tayo. So let's now continue the slide here in a clean slate. Okay, so we are actually left with x minus x naught it's equal to, okay, v x minus x naught is equal to v naught of x times vx minus v naught of x all over a sub x plus 1/2 a sub x times vx minus v naught of x all over a sub x squared. And then we will now simplify each term. So to simplify each term, so x minus x naught is equal to vx v naught of x minus v naught of x squared all over a sub x. Ha! Komplikado, no? It's plus, okay, so the a sub x here will just cancel, so you now have 1/2 times, okay, we have now v x squared, v naught of x squared, okay, minus or minus 2 v naught of x vx, okay, plus vx squared yeah, I guess, yeah. So yun tayo, okay, and then let us simplify this 1/2 here. So to simplify that 1/2 here and the ax here, we can multiply both sides by 2a. Okay, we can multiply both sides of the equation with 2a of x. Okay, so since we multiplied both sides by 2a of x, it will then look like this will then cancel and this will also cancel, but then it will distribute 2a. Okay, so medyo tricky lang yung algebra, but I don't want to be detailed in the algebra anymore. So 2a of x times x minus x naught is equal to, so 2, so tanggal yung a, so 2 vx v naught of x minus 2 v naught of x squared, okay, and then plus, cancelled yung 2, cancelled yung a, okay, so since a squared to so a squared to, so mawawala din yung 2a natin, so plus, so basically it will become v naught of x squared minus 2 v naught of x vx plus vx squared. Alright, so may mga magka-cancel dyan. What will be cancelled? Okay, this one will be cancelled because it's 2 positive and 2 negative. Alright. And then, what else will be cancelled? This one will become, remember that, okay, this term can be combined. So, rewriting it, 2a sub x times x minus x naught, it's equal now to negative v naught of x squared plus vx squared. Okay? Okay pa tayo? Okay, so simplifying this equation now, we are getting vx squared is equal to v naught of x squared plus 2a sub x times x minus x naught. Now, this is our second equation for the kinematics. Medyo tiring lang yung math niya kasi napakadami at medyo tricky lang, but you can do the math. Okay? So, that's our second equation, third equation for the kinematics equation. Third equation. Okay? So, let's have a review. Okay? First equation, we have vx is equal to v naught of x plus a sub x times time. The second equation is x minus x naught is equal to v naught of x times time plus 1/2 a sub x times time. The third equation is vx squared is equal to v naught of x squared plus 2 a sub x times x minus x naught. Okay? So, another useful expression, okay, that we can be using is when we get more equating two expressions for v average of x. So, we can actually get the fourth equation. Usually, di na siya masyadong ginagamit, pero pwede pa naman. The fourth equation uses the v average. So, v av of x is equal to x minus x naught over t. And then v av of x is equal to 1/2 v naught of x plus vx. Okay? And then, since these two average, we can multiply these two average. Okay, we can equate these two average velocity. So, equating them both, so we have x minus x naught over time. It's equal to 1/2 times v naught of x plus vx. So, multiplying both sides by time. So, now we have x minus x naught. It's equal to 1/2 times v naught of x plus vx times time. So, this is now our fourth kinematics equation. Okay? So, to summarize the four kinematics equation, we have, memorize ko na siya. Okay? Not vf. We have vx is equal to v naught of x plus a sub x times time. We have x minus x naught is equal to v naught of x times time plus 1/2 a sub x t squared. We have vx squared is equal to v naught of x squared plus 2 a sub x times x minus x naught. And then we have x minus x naught is equal to 1/2 times v naught of x plus v sub x times time. So these are the four kinematics equation. We will be using this four kinematics equation in all kinematics problems that involves uniform acceleration, meaning the acceleration is constant. All right? Do not forget them, and do not forget how to use them or when to use them. So, yeah, I'll see you next video for some examples.